Great, yes. So I'm going to talk to you very briefly about building a Wikibase from scratch that we've done at the National Library of Wales in order to model name authority data that we have at the National Library. So this is a standard name authority, and we wanted to align these very simple records that we've got for people and places to Wikidata, and then build a Wikibase that sort of acts as a bridge between Wikidata and our own catalog in a way where we can control and manage that data. So we've got duplicate name authorities for people. We've got various sources in the library and with partnerships with other cultural heritage institutions in Wales that have relevant identifiers, and we want to bring it all together in this Wikibase, but benefit from the wealth of data that's in Wikidata too. So we want to make our Wikibase good enough to be a standalone database that people can use, but also aligned well enough to Wikidata that we can do sort of federated querying. So we all know Wikidata is a hugely valuable resource for this kind of thing, but we wanted to build this extra step of having a Wikibase for a number of reasons. So we wanted to simplify that huge complex data structure that's in Wikidata because it simply isn't needed when we're dealing with a small subset of data types, so just people and places relating to Wales. There's also the access. We can control the access and control the structure of the data. So things like our queries don't break if someone makes changes to Wikidata, etc. And then there's the language. So Wikidata is in lots of languages, and there's gaps in places in most of those languages. So we wanted to make an environment that was completely bilingual, where we could guarantee that all the data would always be available in English and in Welsh. And then in terms of content, we just wanted to make sure that we only wanted to include data that was relevant to Wales, but we also wanted to make sure that this could act as a kind of hub where people could go in and access that data as a standalone kind of service. This is a more technical view of our sort of workflow for the database. So aligning all our data with Wikidata, storing it in this Wikibase, and from there we can kind of build tools and write queries and give access to the data in different ways. So this is our Wikibase called SNARK, Semantic Name Authority Repository Cymru. And it's got so far 34,000 people and 46,000 places in it. There's more places than people, mainly because if you want to describe where people were born, where they were educated, all that kind of thing, then you need lots of places. So we found that there's actually a huge amount of places needed in our Wikibase to do those kind of descriptions. So there's a few differences right from the off when you look at items on the Wikibase that are different to Wikidata. So we have a Wikimedia Commons media category rather than just image, and that will become clear why in a moment. You can also see that we have the Wikidata item ID and the URI. We probably only need one of those. I'm not sure why we ended up with both, but we've put them both on each item. And this allows you to align things to Wikidata and allows for that federated query. So for us, this was really important, making sure that as many things as possible could be aligned to their relevant Wikidata item. So another example, we have on Wikidata an external identifier for the Dictionary of Welsh Biography. Now, it was decided when that property was created that it should only be one identifier for one language. So we had to choose between English or Welsh. Whereas, of course, on our Wikibase, we've got the flexibility to just include both so that we can query and easily access IDs to both the English language website and the Welsh language version of that website. We also have a property called National Library of Wales Media, or NLW Media. So this is why we didn't just have one simple image category property. So this actually allows us to, where we have identified people and places depicted in images in our collection, this allows us to state that on those items. So we can give out links on the item about Sarah Jane Rees to images, relevant images about her, that we have in our collection. So to do this on Wikidata, you would need to create an item for the image, have a depict statement that links back to the item for the person. But we've decided to take a slightly different approach on the Wikibase. That means we don't have to create all that extra data. We can just simply link to the images from the person or the place entity. And for place names, we have also opted to use the Welsh Language Commission's standardized forms of Welsh place names. So they've got a big list of the way that they believe Welsh place names should be spelt and used. And as a kind of fellow public sector institution, we've decided to adopt those place names. So this is something that's different to Wikidata. On Wikidata, you have an official place name property, which we've used, but here we've actually adopted the labels for those rather than the community derived labels for these place names. And then we've used a property called source of name form, that allows us to state where that's come from. And in this example, it's from the Welsh Language Commissioner. You'll see at the bottom there, we've also got country Wales. I think this came up briefly in the last session in that generally on Wikidata, if you say someone's nationality or country, it has to be a sovereign state. And that means we can't use Wales in the country or nationality property. So on our Wikibase, we can. No one's going to stop us. We can say that places are in Wales. And if we choose to, we can say that people are Welsh rather than British. And here's an example of a Welsh language item, just to show you that everything is fully bilingual in this data set. So there was lots of gaps when we imported data from Wikidata, and we filled those to make sure that the database is fully bilingual. And we also pushed those translations back to Wikidata as well. So in terms of the kind of general data structure that we've used, you can see here we've got a simplified hierarchy. So there are four main kind of classes of content, and then you've got the subclasses there. And using a nice little interface on the sort of homepage of the Wikibase, we can actually kind of use drop-down boxes and see the subclasses of each of these items. So you can see some of the concepts that we have there. So this was really a process, what we did, of kind of simplifying and pulling out additional subclasses from Wikidata that we didn't feel were added any benefit for us to have in our Wikibase. So for example, there's lots of types of university in Wikidata: collegiate, public, private, research. When we've extracted these and we've created items for universities in our data set, we've simply described them as universities. And the same with cities. So as long as you align that kind of higher class, a city or university, with the Wikidata item, you can still actually benefit from all that granularity that there is in Wikidata. So this is a query in my Snark Wikibase query service. So you can see we've called for all the cities in the database. We've asked also for that Wikidata URI, which enables us to then call the Wikidata query service and say, well, only show me the cities if they are megacities. So this actually returns a list of all the megacities in our Wikibase without us having to have that data in our Wikibase. So this means we can keep our Wikibase structure simple and clean, but also benefit from all that extra granularity that there is in Wikidata. And we've also tried to create kind of documentation and guidelines to sort of show how the structure should be used by people that might be adding content to this in the future. And after some of this weekend sessions, I also want to try and do some data schemas as well. So in terms of the challenges that we faced with this, there is a flexibility issue. So with a very kind of small, limited data structure, it can be tricky to make everything fit. And there's been a couple of times where I've been convinced that I've got all the data structure I need, and then I found I've had to add something else in order to describe something that we need in the Wikibase. We also plan to add information, data that isn't on Wikidata, and of course in that case that federated functionality won't work. So you'll have a kind of two-tier system where the data won't be as rich for things that aren't on Wikidata. And then there's a duplication of effort. So currently we haven't got any kind of automated ways for keeping things aligned with Wikidata. So if there are merges or changes on Wikidata, those have to be made manually, or do a query and search for changes and update our Wikibase that way. So there is a bit of duplication of effort. And not necessarily a data modeling issue, but we've had a few issues with Wikibase Cloud where some of the data hasn't appeared in our query service or is slow appearing in the query service. So there have been a few kind of teething issues with Wikibase Cloud, but I know they're working on those issues. So that's it. This is the URL for the Wikibase if anyone wants to go and take a look. And that's me. Thank you very much.
Thank you so much, Jason. I love the name. And it's really great to see some of the modeling choices you've made and why you've made them differently than on Wikidata, for example. And maybe we can learn something from that also for Wikidata. And with that, we're beaming from Wales right to the office of Wikimedia Sweden to hear about some of their Wikibase projects. André, Alicia.
Yes, thank you. Just a little moment so that we figure out why this window that I was supposed to share just disappeared. It just disappeared. Okay, but if I do this, is it going to... here it is. Here, which one? Which one? Okay. This one. Yeah. This one. Oh, perfect. I hope you can see it. Thank you for your patience. Perfect. So we who are here at the office of Wikimedia Sweden today is me, Alicia Fagerving, and my colleague André Costa. We are developers, and we are here to tell you about a cool project that we have been working on for the last couple months. The project is called Wikibase. You can go and check it out right now. If you paid attention to Jason's presentation, then you can guess where I got the idea for this lovely layout from. Wikibase is a linked structured data database built on Wikibase Cloud, where we collect information about the activities of our chapter. There are things like documents, events, projects, and collaborations with various sorts of partners, such as GLAMS institutions. We've done a lot of them over the years, and it's not always easy to get an overview of everything, especially if you're only interested in a particular subset of this data. Why are we doing this in the first place? Like many Wikimedia affiliates, we do have our own internal wiki where we have been documenting our work. We do try to be organized. We categorize our activities by project and year, and we use both free text descriptions and templates to collect things like the metrics of how many people have attended our events. But turns out the wiki is not easy to browse if you have very specific questions like what have we published about endangered cultural heritage in English or Swedish? Which art museums have we hosted editathons together with in the last couple of years? Or where have we been organizing the most of our events? And as Wikidata has shown, this problem can be solved with structured, linked, queryable data. So how do we go about making our own Wikidata-like database to store data like this? We chose Wikibase Cloud as our platform because it spares a lot of time and effort in comparison with hosting a Wikibase instance on our own server. The barrier to entry is low and it does not require technical expertise, making it accessible to a lot of Wikimedians like us. On a more philosophical level, we have had some thoughts about hosting this data on Wikidata. But is everything a chapter does and publishes notable enough to find its place there? We're not sure about that. So we have settled on setting up our own Wikibase Cloud instance as a safe space to experiment and figure this stuff out, like our own sandbox. And who knows what happens in the future? The work is partially funded by a movement strategy implementation grant. And we're doing it as part of our bigger work with capacity building in the Content Partnerships Hub that we are working very hard to establish. Our goal here is to improve the infrastructure available to all Wikimedia organizations around the world, so that it's easier for them to do great work and learn from one another more efficiently. And it turns out when you want to start a database from scratch, it's just sitting there laughing. There's a lot to think about, like what are things? It can get deep and philosophical because you don't want to just start doing things and then 1,000 items in realize it doesn't make sense. And remember, we're not just doing it for ourselves. We're not doing this for the two of us. We're first doing it for our colleagues at the chapter and later on for our colleagues all around the world. So in the first couple months, we just talked and wrote down everything we imagined Metabase should include and could be, and brainstormed what it might look like. Of course, we want this to be easy to understand, easy to query and edit by others, including other affiliates. And that's why we've set up documentation pages. JSONs are much nicer. And everyone can, in any case, read and see how everything, like an event or a report, could be modeled. Once that groundwork was done, we hired an intern and tasked them with inputting the data from our own wiki into Metabase. It quickly turned out that there was way more complexity to this task than we had imagined. Edge cases, complex series of documents and events, like how do we link a grant application to the project it funded? What do we do if the grant was never awarded, but the application still exists somewhere on our wiki? And together with the intern, we're going through each and every of these issues, and our ontology is getting more and more complex. It is complicated work, and we are very, very far from done. In fact, we're only working on material from one particular year right now. But we can already see some great things that can be done with linked structured data. Of course, being able to run Sparkle queries to answer the questions we posed in the beginning, that's a great thing. For example, the most common locations for Wikimedia's various events. Well, it doesn't really come as a surprise that it's Stockholm, but the data makes it very obvious. We do not want to only support the Stockholm Wikimedians, and I imagine this is something many affiliates around the world also struggle with. Not supporting Stockholm Wikimedians, like their country's Stockholm's Wikimedians. We have made some important choices about not duplicating data from Wikidata. For example, we obviously need an item for Stockholm, but we do not need to store its population or coordinate. This data lives and is maintained on Wikidata, and thanks to federation, we can pull it when we need it, such as here to see these event locations on the map. Of course, big projects are not easy. There is a number of things that we have been a bit salty about. Building an ontology from scratch is hard, not exactly a surprise, but it's one thing to talk about it and another to actually put it on paper. Sometimes paper has been involved and a lot of coffee. Like, let's look at the Wikimedia platforms. They're all neatly structured and organized in Wikidata, but at a level of complexity we absolutely do not need or want to replicate. All we need is to be able to say, for example, we organized an editathon where people edited Wikipedia articles in Swedish. So this requires an ontology that is simple and sufficient for expressing and querying the things we need, like give me all the editathons where people improved Wikipedia in Swedish or in a language, stuff like that. While doing this work, we've discovered that the data we've been maintaining on our wiki is not always sufficient for our intern to convert to structured data. Like in some cases, they've had to find a person involved in organizing an event to ask about the details. And this will obviously not always be possible. Another big question is, how close to Wikidata do we want to be? Close enough to maintain some sort of compatibility. For example, when thinking of a property we check whether there is something on Wikidata already that we can reuse. And when creating metabase-only properties, we really try to make sure it's actually needed. But how granular do we want to be, and will it be useful and understandable not only to us, but also to other affiliates? We're thinking about that a lot, and we're making a compromise between correct, detailed data on the one hand and how easy to understand and query it will be. And finally, especially speaking here right now to all of you, we are painfully aware that our needs, structures, and ideas, they are just ours. The real challenge will come when other affiliates try to join us. Like, does this work for everyone? Well, a great thing about doing this in our own little Wikibase is that at least now we do have a safe space to test those things. And another thing, both we here and our intern and a lot of you are experienced Wikidata editors. It turns out we're set in our Wikidata ways, both when it comes to ontologies and when it comes to technical features. A database in Wikibase Cloud is not Wikidata. We've discovered a lot of things that are just Wikidata things and not available in Wikibase Cloud. For example, gadgets and user scripts, site links, property constraints. That's a great thing that you only realize how much you love it once you miss it. And he's just sitting here laughing. And since for example, there's no Cirrus search extension, so it's harder to search for things the way that we're used to from Wikidata. We have some ambitious ideas about what Metabase could become in the future. For example, a place where affiliates can get information about educational resources produced by others that are available to learn from and reuse within their own communities, so they don't have to reinvent the wheel. Another area that could be improved is collaboration between affiliates. Think about big issues like endangered cultural heritage or indigenous cultures and languages. Like when we in Sweden want to work on a project about the Sami people, then we want to know what our colleagues in Norway and Finland have done. And being able to query for this information makes it much more efficient. We have envisioned some personas, which you can read about on Wikibase, as examples of affiliate staff who might benefit from Metabase in different ways. And the focus here on how the person could use the platform and consume the information. And further, we also envision that there will be in the future a Metabase support team who can assist the personas below with both data extractions and data entry as needed. So if you're still here, you might think this is cool, or you just went to the bathroom and missed all of this. And you might even think you'd like to help us improve our platform in some way. There's a number of questions and issues that we would greatly appreciate some input from the community from. For example, if you have worked with Wikibase Cloud yourself, how have you dealt with the technical limitations that we have mentioned? What do you think about the balance between Metabase and Wikidata? Like, should we try to stay as close to Wikidata as possible, or would it be better to just completely trash that idea and do something completely different? Or, I don't know, maybe that data should just live on Wikidata. And most importantly, what would your affiliate need to get started and contribute with your own data? One of the issues we have been struggling with, especially keeping Wikidata in mind, is, for example, how to model information on budgets and financing. Obviously, this is an important issue for all affiliates, so that's why later today we will talk about it in the data modeling clinic. That will be André who will present the challenges that we are dealing with in this area. So thank you so much for listening. I know that I have posed a lot of questions that surely could benefit from discussing, that we both are really looking forward to hearing. Thank you.
Thank you so much, you two. The Wikimedians in the room are very excited about this. So we have to get to our third talk, but I'm sure there will be many new people contacting you and having questions later after we're done with the third talk. Dr. Yadav is going to talk a bit about the Citizen Science Initiative Semantic Climate. Dr. Yadav, are you here?
Yes, I'm here. Thank you so much. Can you hear me?
Yes, we can.
How do I share my slides?
There, in the bar at the bottom, the third button.
Yes,
can you see it?
See it? That's right. And I can maybe yes. Let me try sharing my window. Can you see my slides?
Yes, we can.
And can I begin?
Please do.
Sorry. So, hello everyone. Good evening or good afternoon or good morning to wherever we're all connecting across the world. I'm Geeta Yadav. I'm a data scientist teaching the
sorry
climate
for
action.
interrupting you. I am at least still seeing your program, your PDF viewer or slide viewer, not the full screen slides.
Oh, I'm on full screen. Oh my gosh. Let me just try again. Can I maybe if I share the whole screen rather than just
that might be best.
That might be better. And I've done that just now. And here I am with my slides again. Do you see the full screen this time?
Yes.
All right. Thank you so much. That was important. So good afternoon once again. I'm Geeta Yadav. I'll be speaking on building a semantic knowledge Wikibase for synthetic phytochemistry. I work jointly in India and in the UK at the University of Cambridge. I'm the co-founder of semanticclimate.org. It's a citizen science movement. And we are very interested in developing AI over NLP to make different kinds of data sets accessible. It was a pleasure listening to the two speakers before me. And my takeaway from both of these talks was that we all do need wiki affiliate collaborations to truly overcome our regional or region specific issues that we have in our research, and particularly for addressing global challenges. So we have been part of the Earth Metabolome Initiative, a global effort to provide, to profile the metabolic content of all currently known species on the planet. And our goal, I'm a very, very small part of this mega international initiative. And my particular role in this is to bring phytochemistry or the landscape data to become available publicly to as many people as we can in this among the citizens. It's part of a national mission in my country, India, the biodiversity mission, and our focus particularly is on climate security. We are trying to unpack plant chemical arsenals using open science strategies, which is what I will talk about today. We've been trying to create the first and the largest machine processable climate to species data repository, and that is what I'm hoping to get help from our listeners today, or inputs or comments about. This repository, we have already are creating it, and we intend for it to be accessible and embedded in Wiki, the global knowledge graph. And we intend to, in the long run, train it to detect as well as predict climate change with minimal human intervention. Having said phytochemistry, I am a plant biologist. My interest is in plant communication, and plants are perpetually always communicating with each other through tiny, visible, invisible chemicals called phytochemicals and volatile organic compounds. Our work is to analyze, detect these emissions, and then analyze them. And in general, how would you know, what chemical is being emitted? Plants are constantly altering their emissions based on the species, the stage, the location of that species, many tissues, other conditions, and a large number of variables are there. Most of this data is published in papers, so we require published papers to extract this data from. And this is just a simple example of one pepper species from Brazil, where all of these different chemicals are being emitted in the oil of the pepper species. You can see pinene, saponine, and you can also see to what extent these are being emitted at. Similarly, this is another paper presenting the same kind of information. The table, you will notice, is very similar. It's got rows with the names of the chemicals. So the chemistry is in the rows, but the columns would have very different kind of information depending upon, is it species, is it the part of the plant, is it the root or the leaf or the flower, or is it 2-4 different varieties, or is it 3 or 4 different locations? And it's very difficult for a human being, or for a machine therefore, to detect what the column information is about, even though the chemistry can be understood from the name of the rows themselves. So therefore, the problem or the challenge we are facing is that all of these different papers with all of the different information have to be put into this repository that we've been creating. And how do we make sense of, how do we automate this without manual intervention? Because there might be hundreds and thousands and more papers there. First problem is we don't have access to all the papers, research papers. So we have an access issue. And so improving access is one part of the work that we do. And of course, a lot of people wonder about access and whether availability is the same as accessibility. And we say that we've been talking accessibility all this while, but we've been doing availability of the data. Our aim is to make every piece of information, just as Wikimedians do, to make it machine exportable, machine processable, exportable, comprehensible, and actionable. And for that, we don't like PDF. So we want to be able to free ourselves from the tabular data sets that I showed you just now in different papers that we get these tables. It's nearly impossible to extract these tabular data sets or the knowledge from these PDFs. And so therefore, most of the time, access to the information that's already published is denied to us. It's the same way with the IPCC 6th assessment report, where we established our tools first, that much of the world's information, the most important knowledge in the world, is always locked in PDFs. And so therefore, coming back to our phytochemistry work, we got help from Carl Malamud, publicresource.org in America, who provided us the metadata of 107 million articles. Now, with 107 million articles having 9,000 plants and information on almost 2,000 different chemicals, I'm in no position to manually extract these tables. And so therefore, we are trying to do it automatically, and that is where we need help. So we've found that there are more than 39 million combined instances of chemicals and plants, and we want to put that into the database that we are creating in Wiki. And the solution that we found is to build a Wikibase RDF data model using where has it gone? Hello, the triplets. We are working on the triplets with, so this is our network of people. There's Peter Murray Rust at the University of Cambridge. There's Simon Worthington, who is at Berlin. Axel is also in Berlin. We have a huge number of intern students in India, both from rural and urban India, who have been building the student authored toolkits for extracting knowledge from PDFs and embedding it into Wiki. And we do all of this by learning. This is our knowledge extraction using AI protocol. Once we've got the final AI over NLP outcomes from the PDFs, which we convert to HTML, and then get the knowledge phrases out, we build a semantic climate workflow. And while creating the Wikibase triple from that workflow, we search for plants, of course, chemistry, of course, and the relationship. Does a certain plant produce a certain chemical? And the kind of triplets, therefore, that we have are plant with a relation and chemical. Pine, for example, makes pinene, lantana lacks xanthine, and so on. The benefits in this is, of course, as the previous speaker already mentioned, and I think it's wonderful that all of us agree jointly that accessibility and barrier to entry to creating Wikibase instances has really been simple for us. The ease of use for interns who have absolute zero barrier to zero background knowledge has also been wonderful. They've been able to do great work with us and expand on the resource creation. But the challenges are things more biological. Challenges are like how to normalize all of this data that we get from different kinds of tables with completely varying names of columns there. And we all constantly find new terms, new variables that come in to modify a plant's emission. Also synonyms. Sometimes a certain chemical may be called something else and a certain plant may be called something else in a different country. So we are trying to now build in Wiki's multilinguality to overcome our issues with certain kinds of synonyms. And we've also had major issues with phrases or new terms, sometimes, which are not there in Wiki already. And we are trying to bring those in by embed them using the Wikibase instance. There are other kinds of triplets we may also have, as I said, for each variable that the plant emits, not just whether a plant emits a certain chemical or not. There could be issues that it emits that chemical only in that location. So then our triplets change and become plant location chemical. For instance, the pine releases pinene, but only in the Himalayas. The rhododendron makes the granotoxin, but only in certain regions such as Europe mostly. In India, it does not make the granotoxins, and so on. All of this information, as I said earlier, has the 39 million combined instances that we've been developing have led to issues with visualizing data. And that is also where we've been greatly assisted and supported by the Wiki model, where we perform automatic indexing using dictionaries that we create out of these words that we have found on the Wiki in our documents, the plant names, the chemical names, and then we try to build an obsidian network out of these to make the text semantic. And as you can see, these networks are interactive. We can test different areas of the written document. We could extract information. We've been able to do it at single document level. We've not been able to do it at large document level, but for now, we've opened access in these multiple ways. And we have been able to, at a smaller scale, make our data available, machine readable, exportable, comprehensible, and actionable. But I would like to end my slides by saying that it's not that easy, and we would love to hear more about, how to make our triplets, how to generate automatically all our triplets using the kind of information complexity that is there in the data, in the papers themselves. You're more welcome to see what we are doing and join us. We are a citizen science movement. You can find us at semanticclimate.org. All of our work is on GitHub, and I take this opportunity to thank my colleagues Peter, our intern Shweta, program manager Renu, and all of our partners, Simon, Axel, and others, for helping me put this together today. I hope I'm in time. I was told there's a very limited time to talk about our work. I hope this made sense. Thank you very much.
Thank you so much. This made a ton of sense. And it's a really, really cool project to hear about. And I'm sure you will find some people here who are excited about it as well and will join you. So we've now heard about 3 really cool Wikibase projects, and we have about 10 minutes time for some questions. So the first question in the chat was, is your Wikibase public at this point? And if so, what's the address? But
I think that question is aimed at me, isn't it?
I
About
think
the
so.
semantic climate. The semantic climate data is entirely public on GitHub, but we've not put the Wikibase instance with it. I mean, the Wikibase instance is not public yet. I'm very happy to talk to you personally, or anybody who would like to get in touch with me. My Twitter ID is Gilienv, Gilenv. I'll put it in the chat box, and I'm happy to, work with you. We want to be able to build it in a way that it's that all the data can be automated. Right now, that's where we are struggling. Thanks.
Great, thank you. There's another question also for you. What is the expected relation of semantic climate with data hubs like Zenodo and so on?
Databases like Zenodo, no, the databases like Zenodo are not phytochemical databases. We put a lot of our information onto Zenodo once in a while. That doesn't, I'm not able to connect. So there are a few phytochemical databases in the world, but they're not contextual. For example, you can find out from PubChem very easily how many chemicals are there in the world and what kind of, also from Dr. Duke's, what kind of plants are making what kind of chemicals. But there, the focus is, each database focuses on a different, for example, what's the biological activity, pharmaceutical value of these compounds. But it never tells you that that compound comes from this plant, but this plant makes that compound only in this location, only during the flowering stage, for example, or only from its leaf or roots of or the tips of the buds or what. We want that information to be in the Wikibase hub that we are creating through by means of these different triplets. Did that make sense? Thank you.
I believe so. And there's another question from Itamar. Can you elaborate more about the usage of Obsidian as a way to semanticize data?
Very interesting. Thank you very much, Itamar. So Obsidian was suggested to us by one of our interns who said that, because I was discussing often with these large number of data sets that we have, and visualizing them becomes a problem. And network-based visualization, because we've seen so much, particularly with Twitter, that a lot of data, large-scale data visualization becomes easier when you look at these big networks of nodes and edges where you can find clusters and patterns easily. And we thought that we could find clusters or patterns in certain plants and certain chemicals by using a network approach. But what we realized was these huge numbers, we can't build networks straight from the data. And then one student came in and said, have you tried Obsidian? Because Obsidian is an interactive network. It could be as large as you want, and you could zoom in as detailed as you want, and it would still become very. So then we tried it with 1 or 2 different papers, and it turned out to be very interesting. And so Obsidian worked with us for visualization very well. But again, automating Obsidian has been a challenge. That's a great question. Thank you. Each word becomes a node. The semantification is that, just to answer Itamar, sorry for digressing, each word becomes a node in the network. And from each paragraph, each section, and from there you could go to other sections, connected sections. So if one plant is let's say lantana, my interest is in lantana, that's a node. I could find what else is being made by lantana in which other regions by moving from Obsidian nodes one to another. Hope that makes sense.
And I don't know if you've had a chance, earlier during the data modeling days, someone presented an Obsidian plugin to connect nodes to Wikidata items. So that
I was going to ask you for a recording of that one because I want to listen to it. I was so worried about my presentation. I have to see it again twice if you would allow me to, the recordings are going to be for all of us. That was wonderful. That was great actually for us.
Yeah. All right, then a question: when did Wikibase Cloud go live in public first? So it's now in open beta since a few weeks, I want to say, but I'm not entirely sure. And before that, it was in closed beta. Then a question for Wikimedia Sweden. Have you tried modeling with data about the WMF's events or budget from Meta to Wikibase, to Metabase?
We haven't, mainly because we realized we know our data better. We know the thinking that went into when we structured our templates better. But we know that is a data source that's already there for some of this data. And unsurprisingly, MetaWiki is also the reason why it became Metabase, because we know that is where a lot of this data can be extracted from going forward.
Cool. And if people want to help you, what's the best way to do that?
Email, probably?
Yeah, we'll put it both in the chat and in the Etherpad.
Cool.
Good.
All right. Are there other questions that people have?
If I may ask a question to Wikidata Sweden, there's right now, we've been searching for partners in Sweden, particularly because we have an open grant by the Indian government for funding joint programs between the two countries. I'd be very keen to connect with you and pull together something, what we're doing, and through Wiki, with Wiki, we could build a much larger repository or a gold standard on phytochemistry, as I just explained under semantic limit. That'll be wonderful if you're open to or if you know somebody who might be open to collaborating with us.
Yeah, if you get in touch, then we can see. I know some people from the citizen science community here.
Yeah, exactly.
Get them in
wonderful. Thank you so much.
And thank you.
And as Jan is saying, matchmaking, that's one of the reasons why we're doing these events. Perfect. Cool. Are there more questions or something you want to let the community know still for the last 3 minutes? Please go ahead, Ismail.
Yes, I put it in the Etherpad. It's not just a question, but a thought. I think we are identifying a common pattern when setting up our new Wikibase instance. Everybody needs to find the ontology they need to set up. So to me, it's clear the need to, in some way, to identify and put in clear and probably, if not implicit or coded into Wikidata, at least completely aligned with Wikidata to fix a potential semantic mismatch. But we need some way a repository of ontologies, of use case ontologies, to ready to be shared and ready to be to fit our instances. I don't know if I has been clear enough. Sorry.
That's very clear. And yes, and as far as I know, the team around Wikibase Cloud is actually looking into this. Okay, how do I even start my first ontology issue now? So let's see what they can come up with. And if people have ideas, please let them know. I'm sure they would love to hear it.
Well, indeed, I'm the initial drafts of kind of design of a productized Wikibase for small GLAM organizations. It's in the just in the initials, and I know an specialist in museology, but I'm finding a clear need. After the GLAM Wiki meeting in Montevideo, I found there is a need, more or less common need, or a solution like this, a Wikibase ready to be used with ontologies, practices, documentation, etc. I would like to talk with you in another moment about this.
Sure. I can get you in touch with the right people. We're almost at time, but we're going to have one last question for Jason here from Tuka. How have you found so far the documentation and community around Wikibase?
It's been pretty good, actually. It's been pretty useful. There's a good group on Telegram for Wikibase, and for Wikibase there's another one, a separate one for Wikibase Cloud specifically, that's really welcoming, and lots of people there happy to help answer questions. If you go to the Wikibase website, there's a couple of really useful case studies. I found the KB First Impressions case study really useful. For Wikibase Cloud, there's some really good examples of federated queries and various sort of hints and tips for kind of getting the Wikibase set up in a good way, being able to set up your language, your preference for languages and that kind of stuff. So yeah, there's actually fairly good documentation out there, I would say, and good support.
That's great to hear. Thank you, Jason. And with that, we are wrapping up this session. And in 9 minutes, we're gonna get back together for modeling heritage, protected areas, and monuments.